We now want to deal with our first metric or our first two metrics. These are relative frequency and absolute frequency. So we are now assuming the following situation. We have univariate data from x to xn. Remember that again. This means that the xi's are all simple numbers, and we want to introduce a first term, once more, namely the concept of size. That is the number n. And as you can see, the number n describes how many data points there are. We will also do another example on the topic shortly. So we have the following situation. So we have these xi's as 1000 univariate data, and what we can also collect now and want to distinguish from the data are the values. We denote the values with a to ak. And so you see, there is no n, but there is 1000. There are actually fewer values than data points, which is simply because two data points can have the same value. Yes, that means, let's just make an example. So we have univariate data 1, 1, 2, 3, 4, 5, maybe another 4. Then the values are just 1, 2, 3, 4, 5. That means k is equal to 5 and n is, let's see, 1, 2, 3, 4, 5, 6, 7. So in this case, n is equal to 7. Well, that is the situation we are in for now, and now we can determine the so-called absolute frequency, which we describe as h to hk. So a new letter h for frequency and 2001. What does h mean now? It counts how often the value a appears in the data. That means in our situation, how often does the value 1 occur in these data points here? And there we see that h is 2, because the 1 occurs 2 times in the data. Yes, and it would then be to see how often the value a occurs in the data. The value a is second, and when you see that the 2 appears once in the data, we might note that down briefly, so h is first. Yes, so far so good. I think everyone knows 2001. We simply count how often each value occurs in the data. And the next thing we want to introduce is the so-called relative frequency. This is nothing other than the absolute frequency, except that it is divided again by the size or the number of data points. Why do they do that? They do it to obtain comparable values for different large data sets, namely a value between 0 and 1. Yes, we can briefly look at what f is. So f is h, which we have identified as 2 divided by the size, which is then 7, so that f equals 27. Yes, so that means it is similar to a probability also between 0 and 1. But yes, we will of course cover probabilities in the upcoming videos. Well, that is the relative frequency, and there are of course relationships between the different types, that is, between absolute frequency and relative frequency. There are indeed formulas, and the first one is that we consider the sum of all absolute frequencies. And now I will give you a moment to think for yourselves about what this sum might be. It is best to pause the video briefly. And if you haven't paused it, or if you have already figured it out, then you will see in 2001 that the sum of the absolute frequencies is, of course, the size. Yes, so when they count how often each value occurs, they get all the data counted once in total. The second formula is that when you add all the relative frequencies together, you get a similar formula that applies in probability theory. Then they take the sum of h divided by n, which means they have to add h divided by n plus h divided by n plus ... This is nothing other than h plus divided by n. But what is h plus h? We already know, namely n, which means we get n divided by n, and that is the first. Yes. So the sum of the relative frequencies is the first. Finally, we would like to briefly provide an example of relative frequency. Let's take a quick look at this. A bookstore has recorded data on books sold in the last month. This data shows how many books from different genres were sold. There are therefore novels, non-fiction books, children's books, and cookbooks. And they should determine the absolute frequency for each genre and the relative frequency for each genre. Let's first look at the absolute frequency. Again, they take a break if they want to calculate it themselves, but that shouldn't be a problem. Namely, A stands for the value. Novels are natural, it actually says so. 120, A is 80, A is 60, and A are 40 and 1000. And what do they do now with the relative frequency? Well, the same values, only that they need to divide by the size. That means we first have to consider what is actually the size, and they get that by adding the values together. Oh, sorry, I wrote A here. That is of course wrong. I mean H, of course. Sorry for that. That is of course the frequency. Exactly. Sorry for the mistake. It's good that it was recognized. And now we will determine the size, which is 100, 20, 80 plus 60 plus 40 is 60 plus 40 not. They add all the frequencies and then arrive at 200, at 300. And now they can simply and without any difficulty take the relative frequencies by dividing the absolute frequencies by a total of 300. All right, we will no longer do this for F and not F, but we know how it works. The last thing I wanted to briefly discuss with you is how to visualize absolute and relative frequencies. And this is primarily done through bar charts, also known as bar plots, which are a type of diagram. And here we see that we can represent the absolute frequency through the height of the bars. The higher the bar, the higher the frequency, thus presented very compactly. And relative frequency, when they can compare multiple data points with each other, can also be represented using bar charts. And they have the advantage that they have scaled everything between the values of 0 and 1. But what they also see is, of course, that the ratios between the individual values do not change. 2001.